Hello everyone! Today, we're diving into the world of paper chromatography. Specifically, we'll explore the retention factor, or RF value. You might know it as the simple ratio of how far a spot travels versus how far the solvent travels up the paper. It seems like a fixed number for a given substance, but in reality, it can change quite easily depending on your experimental setup. So, what exactly affects these crucial RF values? Let's look at the key factors. First, and arguably the most important, is the solvent system, also known as the mobile phase. The composition and polarity of the solvent have a massive impact. A more polar solvent will be better at moving polar substances up the paper, leading to a higher RF value for those substances. If you change the solvent, you change the result. Second, we have the paper itself, our stationary phase. Standard chromatography paper is made of cellulose, which is polar due to the water molecules trapped within its fibers. Using a different grade of paper or a chemically modified paper will alter the interactions between the substance and the stationary phase, thus changing the RF value. Third on our list is temperature. An increase in temperature can affect several things. It can decrease the viscosity of the solvent, allowing it to move up the paper faster. It can also increase the solubility of the sample in the solvent. Both of these effects generally lead to an increase in the RF value, which is why keeping a constant temperature is vital for reproducible results. Fourth, we need to consider the saturation of the chromatography chamber. The atmosphere inside the sealed container must be saturated with solvent vapor. If it isn't, solvent can evaporate from the paper as it rises. This slows down the solvent front and can lead to inconsistent and often higher RF values. A properly sealed and saturated tank is key. Lastly, the amount of the sample spotted on the paper can influence the measurement. If you apply too much of your sample, the spot can become overloaded, leading to streaking or tailing. This makes it very difficult to accurately determine the center of the spot, leading to an inaccurate RF value. A small, concentrated spot is always best. So, the RF value is not an absolute constant, it's a value specific to a substance under a very specific set of conditions. Thank you so much for watching. If you found this explanation helpful and want to learn more, please give this video a thumbs up and consider subscribing to support the channel. Your support helps us create more science content just like this. See you in the next video.